Good evening to all the participants. Welcome to the 136th WiseViews Leadership Conversation. We are joined by Mr. Tharun Kumar. I request all of you to join me in welcoming Mr. Tharun Kumar. Welcome, sir.
Thank you. Thank you.
Great to have you on this WiseViews platform. I'll make a brief introduction and then hand it over back to you. Let me share my screen, please. Yeah, WiseViews Leadership Conversations, as you all know, we hold these on Fridays at 6:30 p.m. in the evening. And today is the 136th session with Mr. Tharun Kumar. He's going to talk about biomimicry. What do we learn from nature? So 20 minutes of opening remarks and 40 minutes of Q&A, the usual format. I take this opportunity to introduce Mr. Tharun Kumar. With over 2 decades of experience in IT and sustainability, Mr. Tharun possesses extensive expertise in sustainable sewage treatment solutions. His career includes diverse technical and business leadership roles, notably with Aujas, Sutherland, ICFAI, Cable and Wireless, Hughes, and Motorola. Mr. Tharun is a Alive Fellow, Leaders in Innovation of the Royal Academy of Engineering, UK, and a certified energy auditor. In his current capacity, Mr. Tharun is dedicated to leveraging ancient knowledge to address contemporary environmental challenges, particularly in wastewater treatment. ECOSTP's mission is to combat the global water crisis by reusing sewage, starting in India. The company has developed a groundbreaking net zero sewage treatment product inspired by the bioengineering concept of a cow's stomach and mentored by the Biomimicry Institute, Montana. ECOSTP's moonshot mission is to naturally reclaim every drop of wastewater, and they have already successfully reclaimed over 2 billion liters of sewage. Currently implementing over 200 ECOSTPs in 24 states and cities like Chennai, Bangalore, Hyderabad, Patna, Kanpur, Delhi, and Goa. Mr. Tharun and his team have introduced a pioneering biomimicry-based net zero sewage treatment technology, replicating the digestive system of cow. Mr. Tharun's contributions have garnered several recognitions. Some of them include the Startup Entrepreneur of the Year Award from the Economic Times Leaders of Tomorrow. Very recently, he has been featured in the India Today magazine under a special series called Republic of Happiness, where 20 changemakers have been showcased. I have first read about Mr. Tharun Kumar there. He also holds a patent in the field of bioengineering for sewage treatment, demonstrating his commitment to innovation in sustainability. Thank you very much, Mr. Tharun, for agreeing to speak with us. I will take one more minute to introduce my esteemed colleague, Professor Prasad. He is the Senior Director in Academic Wing of ICFAI Group. He brings 3 decades of rich experience as an entrepreneur and also as an academic. He is an alumnus of IIT Bombay and IIM Kolkata. Welcome, Professor Prasad, and thank you for being on the panel. And we'll now straight away go to the opening remarks. So, ladies and gentlemen who have joined, this is the 136th session, and we are extremely joyous to have Mr. Tharun Kumar speak with us. Over to you, Mr. Tharun, and thank you very much for joining.
Yeah, thanks. That's a good one. To Sudhakar and Professor Prasad. All right. So, good evening, all. I'll state, as usual, we are all presentation guys. So, we'll put a PPT on to start with, and then we'll jump into the QA. All right. So, this is called Learning from Nature, a small session. A quick intro is a very deep subject, but I'm just taking a small prism so that it can help you more understand. So let's understand what is biomimicry. Biomimicry, she's my guru, Janine. We've been, she wrote a book called Biomimicry, and she started the Biomimicry Institute based out of US, Montana, as a movement. But nothing much is the learning from nature. How do you learn from nature? So 3.8 billion years, nature has been evolved. So there's something will be there. Something survived 3.8 billion years, has to work now, right? So you can just ignore and jump into something new, but something's there for the last 3.8 billion years. So how do you learn this, and how do you mimic this? How do you put it in practice? And I'll give some few examples, and our own example of ECOSTP as an example. So there are very famous old examples. The Velcro was an old example. The guy walked in with a dog, and he had a burst on his body, and then how the Velcro was patented, and that's how Velcro was born. This is a long time old story. Then so after a few years, this became very popular, the bullet train story. So bullet train was making a lot of noise when they go to tunnel, and they just copied the Kingfisher's beak. This is a simple copy, and the noise completely went off. And so simple, no-brainer. Just copy simple things, and then the credit goes to Kingfisher. And this is one of the last quote of Steve Jobs that said the intersection of biology and technology. Biology and technology is what the new innovation is going to come. Always innovation happens in intersections, but biology you have and the technology you have. If we can get that spot, is where the. So let's go some more deeper innovations, which is very interesting. And this was my favorite one, the shark skin one. This is our famous Mike Shep. I don't know how many plus swimmers around in this group. So Shep spun something like 8 golds in the Beijing Olympics. Something. Imagine a human being winning 8 golds. We are starting to get one bronze and silver here. One guy. He won 100, 200, 300, 400, 600, everything. Right? Breaststroke, everything he won. Of course, he was a great swimmer. He always gets gold, but this time he had an edge. He was wearing a shark skin suit. Now, let's talk about sharks. Sharks, apparently, they have small denticles, or not a little skin, a small grooves, which helps them go to the water in a little more faster. Slight edge. It's called drain gain. 15% gain. Swimmers can answer more. 15% gain you get when you swim through, right? So Speedo company copied that in a swimming suit, and then I was discussing with the Speedo company how did that. So it's nice to say Kingfisher is easy. Kingfisher's beak is straight and copy to biomimicry for a bullet train. But this is not easy, because how do you copy a shark skin suit, right? How do you copy a shark skin suit? So that's where the material science comes in. So they used various material and nothing worked out. Then they used ceramic technology. So ceramic technology has improved a lot. So you use ceramic technology to wear this dress. Of course, you can use it only once, then you have to throw it away. But who cares? If you get 8 golds, then you can always keep it with the person. So he wore this, and he got a slight edge. And as you know, in Olympics, the winner and loser is all microseconds. It's not even seconds. So someone gets a slight edge, he or she gets the gold. So that's how he got it. And immediately it was banned. But the point is not about. So a lot of amazing one. This is another popular one, desert beetle. Imagine a desert. Where's the water, right? And how did the nature gets water for the beetle? So beetle walks around. He's got again a small denticles kind of thing, small bumps, which will attract the water, and there's a small groove that takes the water straight to his mouth. So that's it. There's no motor, no filter, no moving parts. It's just shape. In fact, a lot of nature's innovations are shape based. It's just a shape. Nothing, right? So it just go through and he gets water. Now MIT researchers have found something with this, and they started mimicking and doing this. But this is another great example of this. Again, it's all. I'm just introducing few examples. You can go to Google and then learn more, because it's a fascinating science, amazing science, moment you understand the nature. This is another great example. A lot of English, but I'll just take on the few things. It's a book called Bats. You should get this if you're interested, by Mr. Brock and Simmons. Is a detail of how bats works, right? How scientific is or advanced they are in bats. So bats, we all know they're blind, they can't do, but they're very scientific, right? So bats can travel, and traveling is easy apparently. You can even if you're blind of some time, you can easily travel. But how do you, if you're in a tunnel, how do you get the food? How do you know where's the food? Where is my pizza in the tunnel, right? So that's where the challenge comes in. That's where the technology comes in. Right? So they make, first stop is they make the shape, sound. They make with the larynx, tongues, and nostrils. 3 of them. They keep on, again, it's a pure shape thing. Then they change into the pitch, ultrasonic, constant frequency, FM, all mix up. And they vary between them. And each species of bats have a slight change. So it's not, so even if you're ready among one, but another one will come with a different variation. So that's how they do it. And sound is low, 50 dB, and high is 120 dB. So it goes up and down. So, and then you take it back and then you process, then you know exactly where's the food. I know exactly where is I'm blind. So imagine, right? But now The catch is when I do this high frequency and I get back, my eardrum will get damaged because I'm getting the echo back. So they already evolved it. So when the sound goes off, by the time echo comes in, the three bones, that malleus, incus, and stapes, comes in and locks it. So the echo is, and release it. And it's all milliseconds, in 2 to 8 milliseconds. So that's how they do this. Right? And lastly, they have the shapes. To capture the echo, they have the shape. That's all rough shape. And that's how they cut. Now, look at this. How advanced is this? The key point is this was evolved over 50 million years. Human beings are only there for 200,000 years. So 50 million years they evolved. If I'm blind, and if you look at a startup perspective, you can always see, right? If you're a startup, you don't have resources, but how do you do this? But if you really think through, there are so many ways to do this. Now, what is he trying? Why is he getting so? Why he's got such a complicated mechanism, right? And to catch the prey, mostly the moths, they eat the moth. And so all the new techniques, even the latest techniques, the AVAX, the AWACS, the old radars, all are based on the BATS principle. It's completely copy, right? Because what I'm saying is, the copy two things. One is motivation, right? If BATS can do this, I also can do this. My electronics can do this. That gives me the confidence. Number two, a lot of science also comes in. How do you do the variation, pitch, all this stuff? So that then how, if enemy tries to jam my radar, how do I non-jam it? This is where I get the motivation from. I can up and down. So think of an enemy versus how the enemy try to jam the signals and how we recover. So who's enemy here? Enemy is the moth. Moth is also, he's not sitting quiet, right? He also has got few million years of evolvement. So he's got a small feather to absorb the shock. So when echo comes in, he will absorb a lot of echo and he will not give the echo back, he or she, whatever. So this species called as a deaf moth is amazing. The deaf moth cannot be caught by bats today because this guy will just absorb all this thing. So he's got this one as biological stealth coating. So this can help again motivation. How do you escape the radar? How do you evade the radar and go to enemy and come back, right? So and there's a lot of science is happening over this. If a good old moth can do this, why can't I? Why can't I go and bomb and come back without getting caught by the enemy? If I have something like this, right? Because at the end of the day, it's all about principles, right? If you know the science, we can also do that. So it's very interesting of how the moths and the thing work. I can go on, but few more examples explain. This is the goods link. I'll share the link. You can use it.
I'm not able to see the slides transitioning.
Are you able to see the screen now?
Yeah, we can see the screen.
Are you able to see full screen?
Yes.
Okay, I think some challenge here, but anyway, you can see full screen, right?
Correct.
Yeah. All right. Let me. Did you see the shark skin?
Yes.
Yeah, you're able to see that. All right. Beetle. I think I explained beetle. Beetle also were able to see.
Yeah, we can see beetle. Yeah.
Beetle. All right. Now this can you see now?
Yes.
All right. Right. So this was also saying that the way the BATS works, the multi-pronged approach of the BATS sense ultrasonic, and the constant frequency FM, high dB, low dB, multiple structures, and with the sound made by lungs, tongues, and nostrils. And lastly, how does when the echo comes back, how do you manage the echo without you damaging your ears? Right? The malleus, incus, and stapes just come in and they lock up the eardrum so that you don't get that thing. So these guys are very, very advanced, and a lot of this new AVAX and radar are all based on this, right? Because, like I said, two motivation how to do this, and number two, technically how to do that. And now, how do you do stealth? How do you go and bomb an enemy country and come back without getting caught using nature as a model? So these guys are the great model called deaf moth. Deaf moth can't be caught by the bats today because they're very smart. Whatever trick the bat has got, which evolved over 50 million years, they can evade today. But I'm sure they evolved some other way to catch up this soon. So they call it a cat and mouse game between the moth and the bats, and we can learn a lot from this cat and moth game. Can you see the screen now? The
yes.
thing? Yeah.
Yes.
Now this is very interesting. I'll share the link. You should check out this link from BBC called BBC 30 animals, which really helped us learning. So one of them is this, how the new syringes are getting discovered. So the wasp, what they do is they just put a small prick, very small prick, And slowly they widen thing, and another prick goes down, and then eggs are laid and gets out very smoothly without even knowing. Right? Today is not, science cannot do this, but they're working on it. It's like mosquito. So imagine a mosquito prick, and another thing goes inside and comes out without even knowing it is there. So beautifully, so they studied in Oxford. Now they have way to the new syringes can possibly come like this using this particular. One is just completely pain free and it works, but it's not easy. Like I said, copying a biomimicry is not easy because it's not as biomimetics to copy. So how do you copy this? How do you copy a shark skin thing? It's not that easy. Let's move on. Let's move on to the cow. We have a cows. We all know cows are very the most important for Indians. Now, cows has got a unique way, the way the cow's stomach works, which we can possibly use to get rid of sewage, the big sewage problem what we have. Because the cow's stomach has got something called anaerobic bacteria. So that we can extract, and I'll talk a little bit about that. So this is the study done by BBC. BBC team came down and then did a study of this. First of all, let's look at the problem. What's the problem? So the problem today is STPs, the sewage treatment plants, what we have today, is broken. This is where the nature comes and the human science comes in. Last 110 years, this is how you treat sewage. Sewage is whatever wastewater, whatever you flush down in the morning, all goes to one tank in the tank. And you blow air in the bottom. You blow air in the bottom, and you add fresh aerobic bacteria every 1 hour. It's called MLSS process every 1 hour. And that's how, and then water gets treated. But you need to blow air, you add fresh bacteria, and that is power chemicals, and it works. And this is what we've been doing for the last 100+ years. Any technology you take across the world is all this. Right? So it is so strange. Why nobody's thought of anything different. And if you look at India, it's not easy to blow air 20 hours a day because power cut and whole of things. You can't add 1 hour bacteria. 1 hour bacteria is added by the motor, but still every 1 hour on and off is not that easy. So most of them break down. Something like 85% of the STPs don't work. 85%. Right? The results are much higher, but 85 is a very, very conservative figure. 85% of the STPs in this country doesn't work. Imagine an 85% of the air conditioners in this country doesn't work, or a fan doesn't work. Will be a huge outcry, right? But here, no one bothers. So the question is, we asked ourselves is, how did nature solve this, right? Nature cannot do blowing air. It cannot do this blowing air business. Nature cannot add thing, right? So we found a septic tank is a way nature treated waste to some extent, the good old days. So how does septic tank treat to some extent? Because of anaerobic bacteria. So that was the key thing. Anaerobic bacteria is the key thing that actually breaks down the waste. So we focused on anaerobic bacteria. Where do you get this anaerobic bacteria? So then we found a cow's stomach is a great anaerobic bacteria repository. So a cow's stomach is where lots of anaerobic bacteria lives. So we thought of replicating it, right? So like a shark skin story I told earlier. So a cow's got 4 chambers, rumen, reticulum, omasum, which is be copied in a civil structure we call stage 1, 2, 3. Right? And then a cow's stomach has got anaerobic bacteria, which we remove it. We polish it, make it a catalyst, and put back in this STP. And you put bad water in, you get good water out without using power or chemicals. So to take a step back, the way nature breaks down waste is they call decomposing. Everything nature gets broken down to the smallest element. That's how nature works. So you put a log that broken down to small elements. That's how the nature works. So you break it down, and so here, anaerobic bacteria is the one that breaks down to the small thing. You get clean water out, and a lot of chambers. And I'll explain the picture how this works. Like you say, it's all lots of pipes and contraptions. A lot of things are there, clever design, but no, it's all one-time job. You do this stuff. The walls has to be rough because the bacteria has to live. So all the walls are. So how do you make rough? A cow's stomach wall is rough. How do you make rough in a civil tanks? So we use stucco plastering. Stucco plastering is when you make the walls rough. So bacteria has got space to live. And once it's all done, you close it up, and this is how it looks like. It's completely. You can see the screen, right? So it's a children's playground. STP is below this. There are 3 plus 1 stage. The last stage of plants is for cleaning the water further, for flushing purpose. for toilet flushing purpose. This is in Bangalore. They've been using it for the last 4 years. The same water is used back over 1,000 times. Of course, some fresh water comes in over 1,000 times. Same water we flush in goes down by gravity. The stage 1, 2, 3 is the yellow one is the stage 1. The middle one is stage 2, and then water goes to plants, goes to tank. That get disinfected by law. You have to disinfect. So put ozone to disinfect. Goes for flushing. So it's been going on like this for. The only maintenance is once in 2 years. Where the kids are sitting, you have to remove the sand there and use that for sludge. It's a good sludge. It's a fertilizer. That's all you have to do. Nothing else. No moving parts, no chemicals, no operators, and it just works. Net zero sewage treatment system. So even the Karnataka Pollution Control Board also deployed the system now because of this particular feature. So the features, of course, like this, no minimum load, because the nature's invention. Nature cannot say I want only minimum load. So normal STPs need 30% minimum load. Here, no such thing. Minimum load is not required, no power, no chemicals. And of course, customers buy this because the running cost is way low. Something like 2 rupees per kiloliters versus 15 rupees for a normal STP. So huge difference. And that's, I'm not going too much into product features, but roughly these are my customers. We have customers all over India now. We have in Andhra, Telangana, we have Aparna and others, and Oregano and others. We have DS Max, Brigade Group, and Nellore, we have Tata Steel as a customer, Berger Paints. So we have all over India we have. And we treated, like Mr. Sudhakar said, 2 billion liters of sewage treated so far without using power or chemical, 2 billion. And we measure, this is what keeps us going. How much did you treat? So our online, we have a ticker that keeps on showing up. Right. So I'll stop here. I'll move to quickly to the biomimicry framework. Is my last few slides I have. Now, if you have an invention, how do you know what is biomimicry? There is some structure. If you don't have structure, you're gone. How do you copy? There should be some rules in the game because it's a little fuzzy subject. How do you copy nature on what? So we have this biomimicry toolbox. It's a link called biomimicry.org. Toolbox goes very in depth on the 10 links. So they look very common sense thing. Nature uses all resources, but it helps you think, right? If you go through each of them, it really helps you think. I'll take few examples. For example, nature is the only energy it needs, right? And freely available energy. That's a keyword. Freely available energy. Where the freely available energy? They explain. Volcano is a freely available energy. Sunlight is a freely available energy. Gravity is a freely available energy. So gravity. So we use a lot on gravity. And once you get this word called freely available energy, that's gravity, you can dig more on gravity. And how much gravity can you do? Because ours is all gravity based. So how much water can you push without any motor? Okay, I can put a motor and pump it up, but with gravity, how much can I push? So there's a science of gravity, and then you look at this. Nature recycles all materials. That's another one. And nature recycles. So we all know. So if your product, how does nature does all this? How does nature do the recycling? Nature is resilient. Any disturbance comes, like today, more sewage come, less sewage come. Nature is resilient. Now, it's a very simple English. One line. Nature is resilient to all disturbance, but break it down further. So this particular link, if you click on it, it actually tells you more things like how does nature be resilient? It explains diversity. It explains redundancy. What is redundancy? It explains the concept of decentralization. Nature is decentralized. How decentralization works. It explains self-renewal concept of nature. It explains self-repair. So all these are part of that particular bucket called nature is resilient to disturbance. Then comes to the question of nature and optimize, then maximize. Optimizing is very tricky. Nature doesn't grow for growth's sake. Nature's got checks and balances, so it cannot suddenly grow. So all the checks and balances, amazing concept is explained well in this particular one. And the mutual benefit, nature produces all the mutual benefits, like it explains the various cycles, the hydrological cycle, the carbon cycle, nitrogen cycle, all explained in that link. Without the positive time, I'm not going deep into this. And of course, nature runs information. The one I love is that nature uses chemistry and materials that are safe. And nature builds using abundant resources and using only rare resources very sparingly. The nature doesn't use, and that was a huge input for us. Nature uses only, if you look at the periodic table, there are 118 elements, but nature takes only 4, the CH and the carbon, hydrogen, nitrogen, oxygen. That's it, only 4. Nature needs only that much, very minimalistic. Sometimes they take a little more, the NPK, CA, Though a little bit it takes a little more, but 7 more they take. But usually only 4 is taken. That's it, right? So that gives a model. How do you do this? And nature is locally attuned and responsive, and nature is a shape to determine. Now, what we done is, if you go to a website, you can check how ECOSTP matches with ISTEM. You have a product or any product you develop, you should see, okay, what a shape means to, how do you use shape to use, like the shape, for example. So our STP, you can do any shape, long, square, any shape, because the shape is one thing. And sometimes it helps you not in the technology point of view, in the business point of view. How do you make it locally attuned? How do you make it local, right? So it's a very tricky one. When I'm a STP manufacturer, right? How do you make it local? I can't do it local, but it helped you. Okay, biomimicry says I have to be local. How do you be local? So what we do in our business is, we don't make STP. We only give the license. We tell people how to make an STP. And it is, for example, a recently deployed in Ladakh. STP is made in Ladakh using Ladakh material, Ladakh labor, driven from Bangalore, right? So it's using local material. So that's how they do this. We use the other one, the abundant resources. We use only 4. We don't use any chemicals. Right? We don't want to use chlorine. So we say, without chlorine, how do you do this? Because why I'm not using chlorine? Because I want, nature is only 4. Carbon, hydrogen, nitrogen, oxygen. I also want to use only 4. So this is a very amazing toolbox, which actually help you to push your idea through. And this is my last few slides. The links, a lot of this toolbox, Ask Nature. Any innovation you think of doing it, you can click on Ask Nature. This is the world's largest encyclopedia for nature-based invention, and it's free. You can just click on it. You can see all the innovations, including our ECOSTP. Everything is there. Like, how do you, like, for example, how do you design houses without air conditioning? So termites has got a way of building houses without air conditioning. But how can you do with termites? Who has done it? Copying termite design, and what are the learnings from them? It's all there in this Ask Nature. So BBC, this particular program, don't miss 30 animals, and each of them in depth, 15 minutes each. 15 minutes on one particular animal, and how did they copy it. And this particular link called resources, sustainability frameworks, which has got a comparison of all the 10 things what I mentioned. So, for example, if you look at Ask Nature, we have this sunflower Fibonacci secrets. How does Fibonacci thing happens in nature? How do you pack maximum seeds in a small area? How do you do this 2, 4, 6, multi 10, 20 like that? Not 1, 2, 3, 4, 5. Like we have learned to pack the maximum, and how that. So it's all there in this Ask Nature. It is our cow thing. How do you ECOSTP is there in Ask Nature? So you click on it. You can search by collections, the biological strategies, innovations, education. Everything is all there. You could do that. And yeah, this is my last slide. Yeah.
Oh, thank you very much, Mr. Tharun Kumar. This is a fantastic subject. As I am going through, I'm sure all the members in the audience also are quite excited about knowing this. We are thankful to introducing us to this wonderful concept. I think the presentation is an introduction. I'm sure there are lots of details into it, and we are also excited to get into those details with the Q&A. But I want to once again welcome the distinguished members who have joined today on Zoom as well as on Facebook to this 136th leadership conversation. There are myriad ways in which nature teaches us, and if we can pick up a few, I think it will be interesting. For love, for war, and for business, there are many lessons that we have. The moth that goes under the radar is teaching us the stealth bombing. The cow stomach is very, very interesting. It is teaching us a lot of structure to identify naturally how we can work on the STP. And similarly, various other examples that have been shown as inventions in the past. The classic examples of biomimicry are very interesting, starting from Velcro. I think this is a fascinating subject that we have just stepped on, and there are lots of curious questions waiting for you, Mr. Tharun Kumar. I'll request all the members in the audience to raise their hands in the second cluster of questions. The first cluster of questions will be taken up by Professor Prasad. I'll come back for the second. Over to you, Professor Prasad, and thank you.
Thank you, Professor Rao. Thank you, sir, for an excellent overview of how biomimicry can help us with excellent examples. In fact, as we look around in our country, innovation is the need of the hour, and you have provided a good framework which can be very useful in multiple areas. Lots of things which are status quo, lots of things which need to move from status quo because they've got stuck at a certain level of efficiency in all systems. So thank you very much for introducing this. And for those members who are very interested in innovation, I think there's quite a bit to take away from here. I start from the course. Thank you, sir. I start from the first query. Our understanding is that nature has been an integral part of many human societies in the past. I'm sure there have been civilizations which have used nature. Somewhere other influences have overridden the notion that nature is part of us. This is all one system. So what are the driving forces here that which we need to perhaps remove from our mindset? A lot of this is a topic which needs to become very popular. And there are some initial blocks which seem to be there because this should have been popular by now. Do you have any inputs on this, sir?
Yeah, I think we've been conditioned by the way we think things should work. And that's the one which I see is the biggest block. The way, so nature's got answers, but we don't want to learn or we don't want to cope because I'm used to a certain kind of way of doing things. One example, my guru Janin keeps on saying this, if you copy a normal lamp, incandescent lamp, a nature-based lamp, for example, we don't have one yet, but we have lamp. So when you copy, we replicate it, somehow we do all this stuff, you add some sulfur, somehow you do this. It may not lit immediately. When you plug it on, it may take some 10 seconds to come on and slowly it will light. But we can't wait for 10 seconds. I'm used to pressing on, light should come on, right? So, and if I'm used to that mindset, and this is only an example, right? So nature doesn't work that way. Nature doesn't know that you're in a hurry. Nature's not a hurry. It takes some time, centuries. Right? So no hurry. So that may be a little bit of issue. Many of the biogas cookers are failed because we don't want to wait. I want to use to LPG, fast cooking. So this is a huge mindset to overcome. As an entrepreneur, if you create something new, you may not even sell because no one wants to buy something which is nature-based, but is a little slow, right? So that's one of the bottle. But if you take it open, and then of course that's a humongous possibilities. Like Professor, like you said, look around you. There are so many possibilities, and see how we can use your modern science, modern knowledge, and distill and say, yes, this may not make sense now. This makes sense. And this is what it is. Use the modern techniques and try to do the intersection, learning your knowledge versus the nature thing, and see how we can, like the moth example. See, just don't copy it, right? Use your knowledge, your wealth of knowledge, use the moth thing, and then try to integrate, and then you may have a winning product. I don't know, it makes sense.
Excellent. I think, we have got introduced to the subject through your session. Perhaps educational institutions are good forums which can start making people think about this. Now, in terms of bodies of knowledge, you've got fractals and fractal geometry, which is there from nature and which is often used in many applications.
Right.
So, I mean, that's a body of work which is already accepted in maths and then it is drawn upon. What can higher educational institutions do in order to bring this into the mainstream as part of study and therefore exposure to students?
Right. I think one is to clearly acknowledge as a subject. And so, for example, I was in IIT Madras. IIT Madras now have a section on biomimicry. I was there last month. The students were doing experiments on various types of calling it out, biomimicry, and then calling it out, make a small group, get people to participate, let them come out with their own innovations. And then, I think that's a way to, one is to clearly acknowledge that's a science and then do it. Because it's a little bit fuzzy. People don't get it because it's a little fuzzy. I don't know how to start with. So if you tell them that's a framework to it, there's a science to it, and there are examples, then possibly we can do it. Yeah, but acknowledging and making part of the curriculum is something we do. If you look at the Biomimicry Institute of US, for example, one of the reasons they became popular is they inculcate biomimicry in the classroom, in the schools itself. They have a small biomimicry competition happening in schools. Only up to 8th standard they have one competition, then 10th standard another competition. So if somebody competes in a biomimicry competition at the 8th standard and below, they are inculcated at that age itself. Okay? So that kind of awareness creation is actually required in our country, because in our country we are very smart. we easily can take it and we can make it happen, right? That's a unique power what we have. We don't have too much of the compliance issue. Like I brought in try anything new, I can't harm the animal. So many issues will come up. So here I can make it happen. So the only question of awareness.
Excellent. I think what you're saying is the ground is fertile to do it in India.
Absolutely, absolutely.
And then more people need to come forward, and institutions also need to figure out what they need to do.
Right.
Thank you.
So because I said this in US, they said, cow, how did you harm any cow to do this, right? How can you do this, right? So how did you do this? So she's become very, those issues don't have, I'm not saying we should not do this. I'm just saying here is much more conducive to do many of the experiments.
Thank you. Now, we just like to understand this process of, the process by which you mimic. I mean, you have done this in the case of your venture.
Right.
The design process. I mean, how did you mimic it? So can you take us through, I mean, you've given an overview in terms of the cow stomach, but when you want to really implement it, what are the other things that we need to know? Is there something more that you can say so that, whenever we are studying one of these other areas, the process or perhaps a flow chart or something which helps us to think and connect and therefore move from one step to another rather than getting lost just in the idea.
Right. Yeah, so I'll talk about the cow example. So we know that it is identifying what are the key, what makes what the key thing, right? It's not the cow stomach. What is there in cow stomach? So asking few questions, going 2 level down, and we found it is, and we didn't come to the cow stomach straight. We came from the septic tanks, anaerobic bacteria. So anaerobic bacteria is the one that makes the wonder, not really the cow stomach. But how come anaerobic bacteria works so well in a cow stomach compared to the other one? So ask these questions and the way they function. And when you reach this, then you don't do too much research on the cow. Keep the cow aside. Focus on anaerobic bacteria. Talk to the people who are doing anaerobic bacteria research across the world. There are many others. They don't work on the cow, but they work on this. That's why I've said the existing current knowledge, implementing that with the cow thing. And so we have to go deep into this. So in our case, we found this anaerobic bacteria is not anaerobic bacteria. There are 4 things. There are 4 types of bacteria that works. So one bacteria known as hydrolysis bacteria. It takes whatever I flush down in the morning, right? It converts into glucose and other things. And then another set of bacteria called acidogenic bacteria, he comes in and converts everything to alcohol. So we are going, wow, how can somebody convert this into alcohol, right? Another one converts into hydrogen. And the last, a 4th set of bacteria called methanogenic bacteria comes and converts into hydrogen and other gases and all. So there are 4 sets of bacteria. Now we know that. So one is a cow, and then there are 4 sets. Then once you know this, and these 4 sets of bacteria, how they work, this is already functional knowledge. Then we see, okay, how do I make this better? How do I hack it better? How do I make it function better? Because I have my pollution control board rules. I have a standards to meet. One standard is known as BOD. My standard is BOD. I have to reach a BOD 10 purity of water. How do we do that? So we work with various institutes. Like one of the institutes what we work now is IIT Jammu. IIT Jammu, we have a tie-up. Why IIT Jammu? Because IIT Jammu has got a very nice lab, thanks to the government funding, huge lab, a lot of things can be done. So we signed a joint IP, joint commercialization agreement with the IIT Jammu to do research on the bacteria. How do you get better bacteria? And now we found a bacteria anaerobic bacteria which can actually eat chemicals in the lab. Right? So your cow, your knowledge, your expertise, your lab, all has to come together. And you don't be a Superman in this. You try to link it all together. And that's how we do. So just don't get stuck into one thing. You take this and you get existing knowledge, whatever is possible, and then work on it. And it's a win-win for the nature.
I think that is throwing some insight. There are many more things which are involved, and you need to continue being curious.
Correct.
And then dig deeper into each of those dimensions which get exposed, and finally you will get there. Thank you, sir, very much. I will now go to the next question, which leads from here. How did you convert this into a business model? What sort of a business model do you have? So that this finally the innovation needs to pay off and it must be able to pay its bills. So how did you get to that? What is that business model, and what kind of scaling can be done to such a business model?
Right. So before the business model, let me take a step back. Right, why I got into this. Right, you mentioned, Professor, you mentioned curiosity, but sometimes not being in the field actually helps. But I was not in this environment. I'm not an environment engineer. I was an electronics engineer. So I was an IT security expert. So the community which I live, one day the entire sewage was overflowing to a lake nearby. And we all like the lake, but the lake is now full of sewage, and the lake catches fire once in a while. And last time, the fire was burning for 14 hours. I think a couple of years back. So 14 hours, the lake was burning, and we got army to douse it. So it's a big mess in Bangalore. And we are also part of the problem, because I am also dumping my sewage to the lake. That's why, now I have a problem. Lake is burning partly because of me. I'm part of the problem and not a solution. How do I solve it? How do you treat waste? I had to put STP, sewage treatment plant. That's the only way to do this. How we done today? And since I come with the open mind, and me and my friends together, you have to blow air 20 hours a day, and you add bacteria. Hey, this doesn't make sense. How can it's not sustainable? How can I blow air 20 hours a day forever? How can I add bacteria every 1 hour? But that's how. But people in the system, they're already in this. They don't think it's different. And that's how it is. This is how air conditioner works. Right? So there's no other way. I'm used to it and that's how that's how all the books says. All the books also says the same thing. So we've studied books. Nowhere it talks about anaerobic bacteria, anaerobic digestion. It's all about aerobic. That's how the whole thing. So, but it's not sustainable. So then, is there any other way to do? So that pushes you back to the system. And then we came out with this idea, and we tried out various pros and cons. Along with the Biomimicry Institute, we got the product ready and all. But then, to scale up, you need this. It'll get killed immediately, because anything new you're trying to disrupt, right? Completely. 99.99% is mortar-based, filter-based STPs. So if you go there and say no power, no chemical, you get killed. But you get some early adopters, get some few people to be champions, and make them a real champions, right? And then make them get the YouTube video out of them, explain about them, and slowly build up the mass, and then build up the thing. But I would say the primary driver should be there should be a problem, a real big problem. A small problem. If it's a small problem, don't do biomimicry. Because do some other innovation. Because biomimicry innovation to click, you need to have a big problem, and you should have a champion, one champion group to really support you. Entrepreneurship is tough, but any biomimicry thing is tough. I have many friends who are struggling. It's not easy when you say nature-based, because nature-based systems, it doesn't work that as planned. There'll be lots of ups and downs, and you'll get killed immediately. Oh, this doesn't work. Let's move on. So you have to make sure that that really the problem is big enough, and get an initial group of champions and just slowly build it up. Don't expect overnight success, and slowly, and you get 1 customer, 2 customers, 3 customers, and get a team together and come up. Yeah. So these are the few things which we have done. I don't know how we generally done, but these are the challenges which we have done. And like any startup, the party says 1,000 days you have to give it. This is not a one game wherein you can make an app and then 1 month down the line you can sell it. You have to give 1,000 days. That's almost 3 years you have to at least spend on this. So if you're not here for long term, you don't get into this. The nature doesn't understand this fast business.
I think a lot of insights in what you have said. I think the first thing is you brought out the element of purpose, which is very important in any business for that matter. And without the purpose which you have elaborated on, I think this won't get anywhere, because there's a lot of energy that you put in to even identify a solution given the kind of background that you've said.
Right.
So there seemed to be very good purpose. And I think the remaining parts of it, the highlight is that this is not something which is there, which is already established. So business model is getting built up. And you're moving forward. There is a pathway by which you're doing that. And I think that holds for a lot of businesses which are coming up tomorrow. Thank you very much, sir, for illustrating that.
Yeah, just to add on this, you call it purpose, right? So you're a professor, so that's a word, right word, purpose. But if you have purpose like this, you have done a lot of support. One of the things we got is, I'm trying to solve a big problem, big messy problem, and we're trying hard for it. So you get a lot of support across the world. So that really attracts, if you have a good purpose.
Yes, absolutely. If you define your purpose, articulate it well, I think there are more and more people who come forward.
Right.
Sir, I come to the next question. What kind of challenges have you faced? I mean, this is kind of missionary mode in a certain sense. There is a social angle to it, and then you're trying to demonstrate to the world that these things can actually be done, and it's a real problem for everyone. So what kind of challenges have you faced in this venture?
Yeah, in our venture, like I said, I'm disrupting a space where all the entrenched people are there. And it's not a very, it's not a very scientific, or it's not a very well, I don't know, I'm not getting the right word. It's not a very professional environment, right? Where the space, my competitor is not very professional. Is a muck. I'm selling a STP business. So it's like, so lot of this, you try to sell, my competition has got motor filter, they sell motor filters, chemicals, and that also it's survived. So every month I sell so many chemicals, I sell so much power, operators. And if I come and say no power, no chemical, nothing, and that is hitting their business, so they'll not keep quiet. They'll make sure that I don't get business. No, they'll do all the dirty tricks to stop me, and even go to regulator, all the things to stop me. So that was my thing, right? I sometimes say, guys, why don't they understand? I'm a great solution, but many other people don't take it because most of our customers are developers, real estate developers. So real estate developers, they really don't care about environment, most of them, right? Or this, they go the existing what works. I have a lift that works, a normal lift that works for 100. Now, if you go tell them a lift doesn't need power, and I mean, they may not be very excited. But and if someone, the existing lift guy says, "Sir, don't buy this because we don't know it works or not," then he'd rather go with the existing because he just want to do this and get out. So that was the challenge what we faced. But the developer is my customer because he needs a lift. Only he can pay the money, right? Others want STP, but here legally he needs to put an STP because unless he buys STP, see, you can see my background. It's a sewage treatment plant in the bottom. So he's a builder. So he has to put an STP, then only they get the OC, occupation certificate. So he needs an STP. So that's a need. So I had to go to him. But this is the catch. It's always competition comes up. So what happened last year is the regulator, Pollution Control Board, banned our system. All our competition went to them and says, this is something wrong. So they said, the only technology available in this Karnataka is this, I know it's a recorded call, is MBR, SBR, motor-based systems, and anything else needs special approval. And we thought, lock, stock, and barrel, we'll move to Telangana because or T-Hub somewhere, because it doesn't make sense here. Because but we got motivated. Number one, shark skin suit also got banned. So we thought that's way out. So we went to the central our pollution control board seniors, met them, and we found, and he somehow managed to, they themselves tried a solution, and they use for their own product, their own building. So they use for their own building, and then immediately the ban was lifted because one they sorted. So, but it's not easy, right? Why should I why should I go to struggle of getting banned, proving to myself product, and then getting the ban lifted? It's not easy. But these are the few challenges what we face. We still face the challenge. It's a very, very difficult environment we're working on. But like I said, the purpose pushes further.
I think this is another angle that a lot of disruptors face.
Yeah,
and you have highlighted the challenge, and also your resilience and your persistence in what you're doing, and the alternatives that you build up for the short term, moving to another state, etc., and then resolving the problem. I think these are the ways in which you have overcome. Thank you very much, sir. There are some other questions, but we'll move on to the cluster that Professor Sudhakar Rao will.
Thank you very much, sir. I think this is very interesting. What started with a great spirit of inquiry that studies nature with, of course, you'll have to start with loving the nature and also suspend your disbelief that nature can offer solutions to you. So once that is there and deeply you focus on that and focus your research on that, you'll have solutions. So classically, I think someone has to fall in love with it. Our traditional knowledge systems is something that we have not focused on, neither in our curriculum nor in our family discourse. I think that is an area which is found wanting. Once that is done, I think more and more eyes will be open, and our mind also slowly becomes open towards tapping into traditional knowledge systems, and then probably we start focusing, start researching, and then identify the patterns, as you mentioned, and then work on how we copy, imitate, and try and bring in innovations to solve some of the problems that we are facing. So this is wonderful. I think there is a pattern, there's a toolkit that you have already explained to us. Sir, the first question in this cluster is there any role for the current AI algorithms to contribute to biomimicry as a process?
Yeah, I think, we've been debating internally a lot about this, right? So the AI, the current way to do this, the biological functions all works absolutely. But in our case, in this particular biomimicry way of doing it, like I mentioned the case of how can you do Ladakh without from Bangalore? Easy. I can make a huge STP from here and transport it, spending diesel, everything. And now my model is I use local as biomimicry as a framework. I using local materials in Ladakh, local labor, and from here. But then when you do this, it should work. And if the end product doesn't work, then the whole thing collapses. So AI can really help us in the delivery part. Make sure that we have been working on how do we make sure we deliver smoothly without how to make it easy to build. We sell something called a kit, do-it-yourself kit. So a kit, how to make the DIY kit much simpler using AI, right? We don't want to put AI for the heck of it, right? But the main sources, a backend doesn't understand AI. That we're not using AI. But how do you deploy very well? Right? How do you anticipate problems? And we tell them, guys, don't press this button because this doesn't work. All this kind of system can be done using AI, and we are experimenting on it. So that's where we can. But the core system, there is no moving parts. There's no electronics. There's nothing. It's only biology. So we call synthetic chemistry. In fact, ACS, American Chemical Society, selected our company as one of the 20 companies worldwide who work on water because they call green chemistry. So we're doing this. Now, I was talking to my professor in IIT Jammu whether can you use AI for the new set of bacteria development. But again, not very sure because we know a way of doing things. But delivering things and those things, we have humans have a limitation how to do this. That's where I think AI can really help us in our business.
Excellent, excellent. Very happy to know that applications of AI are being discussed in your own project or the joint venture that you have established with IIM Jammu, IIT Jammu, sorry. I think there's a great deal of learning that is awaited in this area, and this is also exciting. Of course, there are a lot of people who are excited when you use AI for the sake of it, but when you're actually solving problems and making your processes and deployment foolproof by using AI, I think that is what is making sense, and then that is really and truly exciting. Thank you so much. There is another interesting question which I want to take up. In the meantime, the members in the audience can raise their hands in case they want to talk directly to the leader speaker here. I'll take up one in the meantime. One of our participants said, nature actually does not discriminate between the good and bad. If it creates humans, it also creates coronavirus. Which models are good, which models are not good? That's the question.
Yeah, you're right. So you pick up what you want to, right? So of course, the nature. So if you know nature, you can possibly, that's why maybe ethical or unethical, you can do some kind of tweaking. You can create a conducive nature for certain things to grow better. Like today's world wetland day. So wetlands are the world way the world works. So we mimic, again, biomimicry, we mimic wetland. We mimic wetland called constructed wetlands. And that wetland has got a whole lot of things. We have got bacteria, the protease, the algae, fungi, everything. So I can play around and say, guys, I want more bacteria. I can know this thing. So some level of thing, nature point of view, everything has to be there, right? All the parasites, everything has to be there. But here I can control because it's a constructed wetland. It's my control. I can possibly do some, but of course I can do much for the larger good because I don't want I want this constructed wetland to be good looking. I don't want any worms there because at the end of the day I'm selling to an apartment, right? So, but nature doesn't understand everything. Nature wants everything together. So some we can do, but some of course we can't do. But some I can put some filters and all to make sure that certain worms doesn't come. I'm giving you the specific answer because if you don't put the filters, everything will be there, right? And that's how nature intended. But so when you copy, mimic, there are certain things which you can mimic without impacting is what in my functionality at the same time without doing too much. Because the way, again, a deep knowledge of science is required. Why worms are coming? Because the way worms are coming is nature breaks down everything down. That's how nature's way, right? So if you put a log, there are termites comes in, there are centipedes comes in to break it down. And then the last bit is where the small bacteria, fungi comes in. So we help nature by putting a filter so that we don't have nature doesn't have to break down the bigger ones. I only come to the small ones. So once you know the science of how nature works, why the worms are there, I can possibly put some filters to make sure that Mr. Worm, don't come here because I'm already done the work for you. So some kind of possible, but yeah, you're right. You really can't do too much about it.
Excellent, excellent. I think this gives us insights into how the nature works and how we can make a choice, because everything will not work at one go. Probably over a period of time, the functionality is something and the applicability is another thing that we need to pick and choose. Wonderful. Of course, there's a little bit of philosophy in that question when the participant raised that. I'm cognizant of that. Well, I have flagged one more question. Of course, there's a response here. If nature had brought corona, nature also has given a lot of medicines.
Absolutely, absolutely.
So the person is trying to balance it. Ms. Chitra Sharma, would you like to ask the question?
Yes, very good evening, sir.
Thank you.
Sir, though I have joined late this session, so not very much clear about this concept.
Yeah. This is about, a quick review is about how do you learn from nature? How do you copy nature? How do you maximum copy nature? So a lot of the inventions come today are from nature. So so I can share this deck so that you'll be.
No, you can ask your question as you typed in the key in the inbox. As a teacher, how we can introduce this knowledge or concept for management students, as this concept is very new and not having in book chapters. That was the question that you keyed in. So
yes. So definitely there are lots of knowledge available today online. I shared some links on how biomimicry can help students, how biomimicry can be a way of life, and so many examples. Right? So one example often quoted is how the human bone works. A human bone is thick in the joint. It's not a flat surface, right? When it's used, there it's thicker, and other places leaner. So if less bone is structured such a way that if less load is coming, the load is less, and very need is joint is more. So lots of things you can learn from nature right in front. If you have the thinking and if you have the biomimicry frames it, and you can, so you don't buy things for the heck of it. So a lot of things can be taught. It's a huge science, and like you, Professor said, you fall in love. That's important. If you fall in love with this, you will get addicted. It's amazing examples, but students are the best way to teach them today, because like I said earlier, Biomimicry Institute based in the US, where we got a mentorship, that's how we got a grant, and that's how we started. They teach students, and they have the competition for 8 standards and below, 10 standards and below, and the youth competition. That's how they inculcate, and with thousands and thousands of examples. Many examples may not work, but at least that will put how nature looks at minimalism, and many of the science, the concepts can be connected to nature.
Amazing. Come to think of it, at our school level, when we start learning at the school level, we spend more time probably looking at newer things like plants and animals and nature with an open mind there. I mean, that's what at nascent stage happens to anyone. But as we specialize, as we move into higher education, we are least bothered about those things. I mean, largely speaking, we focus on various other commercial or the proven methods of economy we focus on, and we try to specialize in, and we try to make money out of that, instead of basing our professions on some of these things as naively or as openly, as inquisitively we had seen during our schooling system. So, sir, when you mentioned that when we have to start it early in school, and that's where probably more solutions and more ideas will come from younger generation. I think it has to start from the school level. So that's a nice point, sir. I was trying to explain that. Ms. Chitra, you want to come back? Your connection was not okay some time back. You can complete your question.
So my question, being a teacher, I just want how I can introduce this concept in my class. Currently I'm taking entrepreneurship. So based upon whatever you have discussed, this seem to be like you are inventing something new, and the same concept or the knowledge which you gain from by seeing this, you can come up with some entrepreneurship business out of it. So can you guide me as a teacher that how this concept I could make student aware about it? Because I never heard about this concept in my books, though I am teaching for the last so many years. So this is something very new, and I think syllabus should also be upgraded for these things.
Yeah, I think the multiple ways biomimicry, like I shared a lot of links you can learn. I can share a deck. But I have a four-hour course which I teach pro bono. I teach in IITs. I teach in recently I teach in BIT, Belur Institute of Technology, so for biomimicry for students. So I have the standard set. I can come and teach, and then you can learn. The students can learn, and then possibly try out some ideas. But I can share a deck to. But this most is common sense. It's nothing new. But yet that I keep what Prof said. First you should love this nature thing, right? Then there are tons of examples, and that will just open up, and sometimes you won't realize, like the standard thing what in the US what the teacher students is, wherever there's a fire is happening, where nature wildfire is happening, the trees have the scales. So when fire happens, only the scales get burned. The trees inner doesn't get scale. Inner is, so when the fire stops, rain comes, the tree pops up again. Only the outer gets, right. So this all, but no one notices this. But when you get this knowledge, wow, okay, this particular tree has got the scales around it, so that when forest fire happens, only the outer area gets burned and inner area is protected. So a lot of this, and how do you protect yourself from the against the same, if and really so, and how do you can learn from nature? If nature is doing this, that will some way you can learn from this. So a whole lot of things are possible if the curiosity, but the structure is important. That will some, otherwise you get lost. You get bored and you will get mixed up. So
great, sir. I think two very important points you have once again reiterated. One is I think we should definitely use this 4-hour course which you are teaching pro bono to our entrepreneurship students who are interested in entrepreneurship as well.
Sure.
Not just general, but in focused on entrepreneurship. I think it might be really useful. The second thing is that I mean, it puts me into another question. Natural disasters also have some lessons for us. I mean, that's a bigger point that you're making. Is there anything on these earthquakes? Is there any lesson there on earthquakes? Is there any lesson there on this huge flooding that happens? When I say flooding, it is cyclonic and storms and resulting in floods and huge devastation that's happening. We only seem to lose there. But have you also lost any lesson there?
Yeah, I think, again, very context specific, but what I would say is go into the framework model, and you have a rule book to go through. So the biomimicry link I sent you, one of them goes deep into how does nature knows that something goes wrong. So there'll be some earthquakes coming here, some water thing here, and how does nature, it's a huge issue with the earth. Always there's a volcano, some rain, thunder. So nature knows that something will go wrong always, and nature is fully prepared. And they use strategies like diversity. How do you do? So word diversity is very powerful in nature, and they explain diversity. Redundancy, one goes down. So redundancy, so the word redundancy is very powerful in nature, and how they do this stuff. Decentralization, not everything is in one place. So decentralized. So anything one gets blown off, other thing is there. Self-renewal and self-repair. All these are nature strategies. How do you manage the disturbances? So what is self-renewal? What is self-repair? What is the difference between these two? What is decentralization? What is diversity different from decentralization? But this framework will give the construct, and then use your common sense and connect back. But nature, by design, it designed for it. But nature knows something goes on. Unlike us, we don't concentrate everything in one particular place. So it's a guide, and of course, then use your common sense knowledge and then connect the dots. But use a framework.
Yeah, the takeaway point is use the framework, and there are abundant lessons for us to learn.
Right,
Some of them that you mentioned is in nature. There are lessons for diversity, lessons for redundancy, lessons for decentralization, and lessons for self-renewal. A few that you mentioned here. These are familiar terms for us, which we try and understand in a different context, in a concrete jungle like that we live in. But yes, we're very heartening to know that there is a connect, and if you have, as we initially talked about, as you have open-mindedness, then you will keep seeing all these things happening from nature, and that's where we can learn from. Thank you, sir. Thank you very much. I will go. If any other participant is raising hand, you can do that. Yes, we are going to share the deck with all of you. I think since this is a new concept, we need to go through this, and there are a few links in the deck. We can pursue that and try and understand a little more about it. But in case you have any question that you would like to ask directly, please raise your hand. In the meantime,
just want to add one point. These links what I sent, these like the ask.org is completely free. And this BBC series, the 30s, imagine 30 series, BBC spent, someone funded them, is all free, 15 minutes on each. Amazing animation. So it's easy to understand. So that knowledge is there. I mean, every school, colleges, they should teach. If you play that surface, people will understand. You don't need anything more. Because you may have a knowledge, but how do you distill to a common sense to a man to understand? So they've done the job. So it's up to us to, instead of watching some Netflix serial, just spend some time and watch 1 or 2 daily. You'll have a great knowledge.
Again, come to think of it, sir, it is at the core of interdisciplinary approach. And that's what we keep on talking about day in and day out. But here is a fantastic case and examples of interdisciplinary approach. We talk about Medici effect. And this is the classic
Medici. This is exact Medici effect, right?
Yes.
The innovation at the intersections is exact Medici effect. And that's how, if you really look at kind of the dots, one dot, you can really get this stuff.
Amazing, sir. Amazing. I think as we talk, we are also getting curiouser and curiouser about this thing. I'm sure all of us will go back to it and learn a little more.
Yeah.
Of course, we'll use those .org links that you have mentioned. We'll keep learning and also look at the BBC animations that you mentioned.
And what Professor mentioned is good. The Medici effect book, if you read, and that's also, it's actually a biomimicry book. Then lose about biomimicry, but a lot of like the termites example, how the termites is another, how do you do air conditioning today without using an air conditioner, how termites does it, and how the innovation happen in intersections. So that book is an amazing read.
Exactly. You know, innovation happens at the intersection of domains. I think that's the takeaway. And that's once again being reiterated here. Sir, one question I have. Can you elaborate something on the educational resources for individuals and professionals interested in learning more about biomimicry? Those links or anything else other than that you have?
No, that's all I have, the links here. But if there are, like IIT Madras has got a small group we started now, the biomimicry. There's you can send a mail. I'll send you the mail, and there's a group. And they collect a lot of knowledge. It's happening. This again, a lot of knowledge is happening in bits and pieces. So they're doing a lot of job in collecting all together. So that's one resource pool you can dip into it. So that's one thing I can think of. Yeah, but yeah.
So one leading question, which is just top of mind, is that in these innovations, you take, for example, ECOSTP. What are the success metrics? What measurable success metrics can be attributed to biomimicry innovations? With specific reference to ECOSTP.
Yeah, in our case, we have to make our innovation is very specific to sewage treatment, and sewage has to be treated as per the laws of the country. So there are various government norms. I don't care what you do, but water should be treated by so and so. So there's a standard called COD. Chemical oxygen demand should be less than 50. Biosignificant oxygen demand will be less than 10. So the rules are already made. So whatever innovation you do has to meet that. Otherwise it won't work. It won't be accepted. It won't be. So that's, fortunately, we have that measure. And sometimes nature cannot meet those stringent norms. I'll give you an example. So BOD3 is a very stringent standard, biosignificant oxygen demand, and so we meet 10, less than 10. So Kerala has got a new standard now called BOD3. BOD3 is extreme. We're talking about purity, almost like pure water. Right, almost drinking quality water. How can I make drinking quality water from sewage naturally without powder chemicals? Not possible, right? Because when I go up to some level, so then I may need some additional filters, man-made filters to reach the standard. So you need to be cognizant, right? Certain things you can. There's a push. There's a limit how much you can push with biomimicry. Beyond a point, I'm giving specific example. You need to have additional filters, but you don't need the whole filters. You get the water up to BOD10 quality water, and then you add a simple filter to get to the next level. That won't cost you much instead of doing the whole hog again. But you have to accept that nature has got a limitation, because this BOD3 rule is a rule made by humans, not by nature. Nature never had this rule. Nature never thought sewage would be converted to drinking water naturally. It's not possible. But when human beings make the rule, nature will struggle sometimes to reach that thing. But to a large extent, we can do this. And anything we do, there has to be a construct. Like I said, don't look biomimicry only from the product innovation point of view. Look at the way of life, how the company is organized, how is the org structure organized. All can be looked into the biomimicry perspective. There's a book called Biomimicry for Organizations. So it purely talks about organizations. How did the current classic thing and all, nature doesn't understand this classic general manager, VP and all. It's all man-made something. How does nature evolve the system? That's a good old geese system. The way the way they form in V formation, how they form in when they form in the V formation, they fly together. The geese, they get some 71% higher torque because they all, one is flying in the whatever the air lift of the next geese, and the geese that's going in the front will always take a round back. So a whole lot of examples of how nature does leadership, nature does is all there. So look from the biomimicry, from the when you build up an organization, we look from that perspective also. We try a lot to make sure that we become a biomimicry based organization, not just a technology. Tech, okay, we have the cow, we know that, but how do you make sure that? And that's where we are used to this hierarchy is the way to works and way it works, and so there could be some clash sometimes, but there's one way to look at innovation from the as a whole. Then you're completely holistic.
Oh, thank you, sir. Thank you for even reminding us about the V formation, V flying.
Yeah, V flying. Yeah.
The migratory birds, they fly long distances, like thousands of kilometers.
Yeah.
Across adverse temperatures.
Right.
Without actually falling down, because they fly in a format called V flying, where the leader bird does the lift, aerodynamic lift.
Yes.
And at the edge of the wings, you have two other birds. They do 80% of the labor, and the birds next to these two birds, there's a third level. They do probably 60% of the effort that is put in by the leader bird, so on and so forth. I think the aerodynamical lift will make the last bird almost fly free, like a passenger. And then when the leader is tired, they take turns. So there are lots of lessons in this. And the way eagle reinvents itself, this is also another thing that.
Oh yeah, right. Yeah, that's another one. The way eagle glides, they don't unnecessarily flap. They just glide, and you can just glide and go thousands of miles. Yeah, so all are learning from nature. So that can be utilized. Yeah,
absolutely. I think after say a few years, the eagle becomes old. So its feathers become heavy, its claws become not sharp, and the eagle is failing to catch the prey. So at that time, what happens is it breaks its beak against a big rock, and then a sharper beak emerges. And then with the sharper beak, it plucks its feathers, and then it has got new feathers, lighter feathers to go to soar high. And then new claws, the claws are plucked out, and then the new claws come. That's a process of reinventing oneself, renewing oneself, which we all have to learn from. You have triggered this thing. That's why I'm citing these examples.
Yeah, no, that's great. Thank you. Yeah.
Thank you, sir. But I have another question before others raise their hand, and that question is: you have this patent for this kind of ECOSTP. How is this working in other countries? In India, yes, there is a connect with local knowledge. I'm sure there are cows abroad as well, so this is not alien. But are Western countries a little ahead in using such concepts, because there is no power consumption, there is no chemical consumption, and basically the costs are very low, and it is much safer and sustainable. So are there examples of other countries using this more advancedly than us?
No, not very surprising. No, again, like I said, in India we have a very frugal mentality, right? We started this because no power. Globally, power is not an issue in many places. There's an abundance of power, and many countries, waste is a government resource. The government takes the waste, collect the waste. You have no right to your waste. So the government collects the waste, takes it out, and then centrally process it. When you do centrally process it, then you can't do cow and all. You use motor filters to do it, because I'm taking a large chunk of sewage to one particular place and do stuff. Decentralized treatment is mostly an Indian concept. In India, every apartment or building has to have an STP on their own. Decentralized is a good thing, but those are in Indian this thing. And other thing is the knowledge is, like I said, most of the countries, they use standard filters, motors, and that's how it works. And power is not an issue. But now the slowly is changing, because net zero is becoming a huge thing. Carbon thing is becoming an issue. So they know that the power is generated, like if you look at India, the power is generated 70% from coal. 70% from coal, and now now the coal, now the coal is coming from, a lot of coal is coming from US and Australia, right? Imagine the coal coming from US, and then I'm generating the coal here. It just doesn't make sense. I would rather go for a net zero kind of STP. So those are coming down, that net zero awareness, because there's slowly this kind of concept can catch on. So we are hoping that will improve better from there. Yeah.
Excellent, sir. Excellent. One of our participants wanted to share an experience with you.
Please.
What he has seen in Bangalore. Mr. Srinivas Rao, please go ahead.
Not very audible. Speak a little louder, please, sir.
Okay, I'll explain.
Yeah.
Mr. Srinivas Rao had an opportunity to stay in one of the flats, namely Bhuvana Nivat in Vartur in Bangalore, and all the inmates are very happy with the ECOSTP installed there.
Oh, okay.
Is that property ECOSTP done by you? That's what he's asking.
Can you repeat the name again? The place called
Vartur.
Yeah, Vartur, and which name of the
Bhuvana Nivat.
No, I'm not able to recall. Maybe.
Okay.
Yeah.
It must be one of your projects.
Yeah, right. Yeah.
So, in the meantime, what I request Professor Prasad is to come in for a question or two. He had a few questions which he reserved. Over to you, Professor Prasad.
Sir, this is now directed at individual behavior. And one of the major challenges we face currently globally is conflict. So, since you have read quite a bit about this, do you have any primary suggestions which will help the kind of to minimize or to avoid conflict to the extent possible, whether it's at individual level or at country level or organization level, using biomimicry?
Again, like I said, nature has got all the solutions, and so biomimicry should, the way they always say is any issues comes to be asked, how would nature solve this? If it's nature, how did nature resolve this? One line, how did nature resolve this? And then you introspect, and then possibly you may find an answer. So that's the only thing you can think of. Any conflict comes up, ask yourself, how will nature resolve this? Right? So nature's got a way of making sure one small is there, one big is there, there's no conflict, there's nothing like one winner, one loser, everybody wins. So that's a great model, nature, the way anything you see it. So that's it. But this concept is all powerful tools, which we use a lot in our organization whenever issues come. How will nature solve it? So try out this technique. It looks like sometimes in world you need only simple intervention. You don't need very complicated things, right? How do you? So that's how we can possibly solve it. But again, it's a very deep question, so I don't have a specific answer. But there's something close which you can think of.
Thank you very much. I think some of the others have already been responded to in the earlier queries.
Yeah, one last question. On the face of it, it is repetitive, but the question is along the sustainability axis, because that's a big challenge across the world. Sustainability for us is a big thing for the world now. Are there any one or two pressing areas in your mind about sustainability for which you are looking for solutions from nature?
No, carbon is a huge issue. The carbon is a big issue. So, and the way we look at carbon is, I'm hoping nature has got some smarter way to do the carbon thing, because maybe I feel that we're completely wrong, because now we have many startups that come who can capture carbon. You can nicely capture carbon and put in the rock and put it down and down. So they look nice, but there should be some other way. How do you capture the carbon and convert it into a tablet and put it bury down? So carbon reduction is something huge. And there should be some way. It's a big issue. Why is a big issue? Because we crossed the 400 ppm. 400 ppm is the carbon of how much CO2 can be in the atmosphere. We've been already crossed. Last couple of years, it's been crossed. 430 again come down. We already in that zone, right? So we are already there. So there will be some way nature can solve this. Right? Definitely. One way to look at it is if you have a lot of greenery, a lot of forest comes in, you should absorb the carbon. But that doesn't sound like the way. The oceans, they can absorb a lot of carbon, right? So there are a lot of pointers how to do it, but there could be some other way which nature can possibly solve, because the current way, the human thinking, right? Let me capture the carbon, and this is not, I don't think it's completely unnatural. I don't think that's a right thing. There'll be some other way which nature teaches. But this is where everyone loves it. Okay, I have a quick solution. I have carbon, let me put a sponge in and absorb it. Right, so and you get a lot of press, lot of funding for it, but that should be some way nature can possibly solve it. we are all thinking, but right now that could be, but nature should be having some way to crack that. So I'm sure work is on it by someone.
Amazing, sir. Amazing. It is one of the biggest problems. How does nature capture? Are there any solutions the way nature can capture carbon other than diamonds? I think that's what is.
Yeah, and we are very close. For example, the many of the they say the biggest carbon issues are in Indonesia and all that. A lot of trees have got the roots have got carbon embedded, and if you disturb the trees, the whole carbon get released and becomes much more. So that doesn't look very. So nature trapped the carbon, and suddenly when you disturb it, it all get released. So that's a way to capture thing also by naturally. So that should be. I'm sure there'll be some other way, simpler, smarter way than the current method of generally capturing from the atmosphere. Because how much can you absorb from the air?
Yeah, exactly. Thank you, sir. Thank you so much. I think these are the questions that we have, and we are also going back with one major problem. I mean, in your template, you have also said that you need to have a major problem on hand for which you are looking for a solution from nature. I think we have a problem capturing carbon. Of course, many other issues related to sustainability and non-sustainability as well. There are issues that one can learn from nature. I think this session has helped us look into, if not deep dive, it has helped us look into a new area, and it is hinting at 4 or 5 major things. One is the spirit of inquiry and inquisitiveness and curiosity, which is fueled by love for nature. I think that's a big starting point for all of us. The second one is the intersection of domains. Intersection of domains in a very big way is happening. I think there are no other theories, there are no other examples that are already captured in the book would do as much as you would get from biomimicry examples. I think intersection of domains has been very clearly and strongly explained. So it is a motivating experience for us when we have gone through this one. Third, the template or the formats and the patterns will have been picked up. We need to move faster, not in the sense that we don't have patience to wait for the solutions to come, but in a way that we reduce our thinking and action into a format and then look for solutions. Try and replicate that in a workable solution. I think that is the format you have given us. And the fourth and the very important thing is we need to start this because this is about breaking conditioning. This is about breaking mindsets. This is about opening our minds to something new. Is starting early in schools. Youngsters and young children will have to be open to these kind of things by incorporating it in the curriculum itself. And parallelly, if it is in these schools and tech schools and higher institutes of higher learning, we need to directly relate this to the entrepreneurship cells, and it also has to be part of your curriculum in one way by allowing us to catch the ground that we lost. I think from that sense, we need to move faster and expose our students also, those who are particularly hungry for entrepreneurship on one hand, but on the other hand, at a school level, for us to open up our mind towards this multidisciplinary learning and multidisciplinary skills, learning from nature. These are broad lessons that we have picked up. And I can't thank you enough, sir, for being so patient in answering some of the naive questions. Some of them probably looked silly, but such is the subject. We are exposed to it for the first time. So I want to, on behalf of ICFAI Group, I want to thank you for providing us this construct, providing us this space and opportunity for us to learn. And from here on, I'm sure all of us are going to learn a little more, and our focus will be much better on this biomimicry as a concept from now on. We will also request you to visit us. We have a business school in Bangalore where you live. In all the cities that you have established your ECOSTPs, we have a business school or a university or a tech school or a law school. So we'll try and match you in the sense that we'll try and request you to visit us.
Sure.
Wherever it is possible, because it's a huge boost for the youngsters to talk to pioneers, talk to innovators, talk to people who have focused on things hitherto covered, hitherto not touched. So it's going to be very, very interesting and motivating for us to have you on our campus as well. At the end of this session, what we'll do is we'll attempt a summary. We'll share that summary with you. I request you to email or text me the deck that you have used.
Sure.
With the help of that, we'll attempt a summary and share with you. Once you approve, we'll put it on our archives also for them to understand the methodology, the toolkit, and the structure part of it. How do we approach it? I think it's going to be a good learning tool for all of us when we look at that summary. And this edited video will be put up on our archives as well.
Yeah. Okay.
We would like to have a long-term learning relationship with you. We want to learn from you, and we'll keep in touch with you, and we'll keep bothering you, sir.
Sure. I think thanks a lot. I also was reminded of the Medici effect. A long time back, I read the book. Yeah, but the intersection, again, there's a book dedicated for intersection. So I just remembered that. So thanks for reminding that. Yeah.
Thank you.
Yeah.
Thank you so much for this opportunity.
Yeah,
Ladies and gentlemen, we'll meet you on February 9th, Friday, 6:30 p.m. with yet another leader. Till then, read more about biomimicry and go to the BBC link, which we are going to share with you, and learn a little more. Get excited. I think at excitement is the higher energy. At higher energy is the higher inquisitiveness. And I think at higher inquisitiveness, a lot of research takes place. And when a lot of research takes place, some innovation takes place definitely.
Wow. Yeah.
So thank you so much, ladies and gentlemen, for joining. We'll see you next week, and have a good weekend. Good night.